Okay, so we need to sketch a graph of that function. I'm going to begin by factoring it so that I can kind of observe what's going on with it. The bottom of that factors to be, looking for two numbers that multiply to be 20, that add to be 12, and those numbers are 10 and 2. There we go. And the top of it factors to be 4 times quantity x plus 2. Now that I'm looking at that, I can see that there is a common factor of x plus 2 and x plus 2, and that's where the whole comes from in the graph. And so it would be the opposite of 2, negative 2. The vertical asymptote is going to come from this thing. X plus 10 means that there's a vertical asymptote at x equals negative 10. I'm not going to know the horizontal asymptote unless I look at the graph of this function on, say, a calculator. The methods for finding horizontal asymptotes are beyond the scope of this class, but it turns out if you stare at it on a graphing calculator or something, it turns out it's the line y equals 0. So I'm going to get those spots on the graph. So negative 10 is over here a ways. That's going to be my vertical asymptote at negative 10. And this graph ends up just doing this. Actually, just a pretty regular looking graph. It snuggles up to those asymptotes, something like that. And then there should be a hole on the graph over here at negative 2. So I just put a little circle up there on the graph, and that's the end of the problem. Now we need to simplify and find restricted values. Very similar to the first problem. The top of letter A, two numbers that multiply to make negative 16, add up to negative 6. I think those are negative 8 and positive 2. In the denominator, looking for two numbers that multiply to make negative 24 that add up to negative 5. That's going to be negative 8 and positive 3. So because of that, we can see that those x minus 8s cancel off, giving me a final answer of x plus 2 over x plus 3. And then when we're looking for restricted values, we're looking in the denominator, and we're trying to figure out, are there any numbers I could stick into those x's in the denominator that would cause a 0? Well, yes, 8, because 8 minus 8 would be 0, and negative 3 plus 3 would be 0. So my restricted values are x is not allowed to be 8 or negative 3. Moving on. Letter B, at the top of that one, the numbers 6 and 8 can both be divided by 2. So I kind of pull a 2 out like that and put 3x plus 4 into there. Notice 2 times 3 is 6 and 2 times 4 is 8. So in the denominator, I can divide both of those numbers by 2 as well. And that gives me this. Those 2's cancel out, giving me a final answer of 3x plus 4 over x plus 2. And the restricted value would come from the denominator. What number plus 2 would be 0? That would be negative 2. Letter C, the top of that, factors to be x plus 2 and x plus 3. Because 2 times 3 is 6 and 2 plus 3 is 5. The denominator can divide 3 and 9 both by 3. That gives us this. And then those cancel out, giving us a final answer of x plus 2 over 3. And that tells me, because of as far as restricted values, because of the x plus 3, that means the x is not allowed to be negative 3. Number 3, we are looking for the sum of that trinomial, and one of the answer choices is supposed to come out to be 5x squared plus 3. So in other words, they want us to understand that we need to take this plus a answer choice, and that's supposed to come out to be 5x squared plus 3. Now, so as you look at these, I need sort of this number plus, some number x squared is supposed to come out to be 5x squared. So you might consider that would need to be 7. Because -2 plus 7 would equal 5, and so that just eliminated several answer choices. The middle number, it's probably a better indicator here because you can see that this number plus something with an x on it would need to come out to be, well, shoot, there isn't anything. So we need them to basically cancel out, and so that would end up needing to be a -2. Again, just understand 2 plus -2 would come out to be 0, so it's not even there. So looking back at our answer choices now, we can see it's got to be letter C. Number 4, given the functions x minus 5 and 5 minus x squared, what is f of g of -4? And we call this composition of functions. The idea here is we're going to take the -4 and we're going to stick it into the g function. So I'm going to find g of -4 first. So that's 5 minus -4 squared. Notice I put those parentheses around it. You can type that in a calculator, but -4 squared is 16. Please understand that those little negatives don't cancel out right away because of the squared. The squared has to come first, and that squared cancels out that negative, leaving the minus sign still there, and so that comes out to be -11. So now I take the f function and I put -11 into it, and that would be -11 minus 5, which comes out to be, like, I just took that and just put it right there is all I did. That gives us -16, which is answer C. Okay, good job doing your homework. So notice there's a problem on the back here. Let's see, which of the following values is a 0 of that function? So, probably the easiest way to do this would just, if you were in a testing situation, would just be to take each of these answer choices, stick them into the x's, and see which one gives you 0. It's not the only way to do it, but that's just probably one of the easier options. In other words, take the number 3 and go, is 2 times 3 cubed minus 5 times 3 squared, sorry, minus 12 times 3, does that give you 0? I don't even know. So 2 times 27, that's 54. 3 squared is 9, that's 45. Minus 36, that is not 0. I don't even know what that is, but I can tell it's not 0. Trying again, so 2 times 2 cubed, just checking the next answer choice, minus 5 times 2 squared, minus 12 times 2. Does that give me 0? Well, that would be 2 times 8, that's 16, minus 20, minus 24, that's not equal to 0 either, so. The third answer choice is a little bit harder, but it's since you'd be using a calculator, it's really no trouble for the calculator at all. Just take all that and type it in just the way it looks, and check and see, does it give you 0? I just checked on my calculator and it did, so that's true. So that's my answer. The other major way of solving it, you can stop watching, you can get your answer, but you could also try factoring if you wanted to. So if I take 2x cubed minus 5x, it's not writing, sorry. The first thing I notice is that there's an extra x in all of those terms. So I can basically factor out an x like this. And again, I'm actually setting this equal to 0. This x out here implies that the number 0 is a 0, but 0 is not on our list, so I can't even choose that one. So I'm just going to let that sort of disappear. Don't care about it. The rest of it, I'm going to try to factor into the product of binomials, just like we normally do. The tricky part is that this is harder than the ones we've been doing in class lately because of that 2 in front. So what we used to actually do is go use the box, and we'd put the first number into the box, the last number into the last box, and then we would take, 2 times 12, sorry, 2 times negative 12, that would give me negative 24. I'm looking for two numbers that would multiply to make negative 24. That would add up to be a 5, and it turns out it would be 3 and 8, or more in particular 3 and negative 8. So you put those in the box like that, and then we try to factor out the rows and columns. So greatest common factor of 2 and 8 would be 2x. Greatest common factor of 3 and 12 would be 3. Greatest common factor up here would be x, and finally negative 4 goes into 8 and 12. So there's your factored answer, 2x plus 3 and x minus 4. So this guy right here tells me that x equals 4 is a 0, but sadly that choice is not up there, so that's annoying. So it turns out this is where your negative 2/3 comes from. If you take this, I'm sorry, 3 over 2. If you take this and set it equal to 0 and, do your little solving stuff, you get that fraction. That's probably how it was intended to do, but that's the longer version of the problem, probably.